Hey guys, Mr. Eng here. Let's go over this chapter 1.1 test. Excuse me as I don't know how to pronounce these perfectly. Mano and Shira were asked to find an explicit formula for the sequence. Okay, so don't worry about explicit, but you just have a sequence of numbers. We've talked about numbers before. And so they have these, each of these, Mano and Shira have these formulas here, and so we have to figure out which one is correct. So what we've done is we've numbered them. This is the first, second, third, fourth number. So you can make a table of values. We'll call this X and the Y. This is the number in the list, and this is the corresponding output or number that we have. Well, what can we do? Here, I know that this is a plus 1. This is important because this basically tells us if this is a function or not. Over here, I want to figure out if this is multiplying or adding. If it is multiplying, which we do have, looks like it's multiplying by 3. Okay, so then, if I know it's multiplying, this is called a common ratio. With a common ratio, we basically have the form y equals ab to the x power. This is exponential. And you have your foldables. And so, the number you're starting, your common ratio is the red one. In that case, we have 3 above. And the a value is the starting point. Okay, so we have to do something here. We have to figure out is for 0. Well, just think backwards. This is still 0 plus 1 equals 1. So I need some kind of number. Let's use some kind of number that when we multiply by 3, you get negative 9. And that would be a negative 3. Negative 3 times 3 gives you negative 9. So this would be my formula. Trying to box that, it's way too big. There's my answer. So let's look at one of those. And the only person who has that is Shira. So Shira is the correct answer. Now, how do you check that this actually works? This is important because you want to know if your answer is correct or not. Just plug in values. So Mano's, if you pick n equals the 1, right? Negative 9, 3 to the first power. And I expect the answer to be negative 9. Well, negative 9, 3 to the first power is just 3, which means it is negative 27. Okay? Negative 27 is not negative 9, so Mano's does not work. Okay? Let's try this with Shira's. Okay? Negative 3 times 3 to the first powers, because that n value is the 1 that I'm talking about. And 3 to the first power is 3, so negative 3 times 3 gives you negative 9. And that is negative 9, so that's another way why Shira's works. Okay? Alright, question number 2. Analyze the pattern, and then we need to, it says, which algebraic expression represents the pattern? So, again, I'm going to make a table of values. And there I have the design number. And over here, I'm going to have the total of, I don't know what to call them, mountains or triangles, okay? So let's see what we got. I see that we have 1, 2, 3, 4 in the first design number. In design 2, I have a total of, let's just count, 1, 2, 3, 4, 5, 6, 7. So we got 7 here. And I notice, I'll do it by color in a second, but I'm just showing you guys by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So design 3 has 10, and then design 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this is what I saw as the pattern. See if I can do this by color. Okay, here's my 2 in yellow, and then this, I have to call it these 3 right here. And then you have the original design. So the original design had 5 and 2. These 5 is what was in the previous design, right? Right there. In yellow. And then what we added was just this red triangular V kind of thing. And same thing. Design 4, I'm going to highlight the previous design. So in here I'm going to highlight design 3, 5, 3, and then 2. So kind of like this weird looking mountain of mustard or something like that. And then the 3 is right there. Okay? Alright, so let's do what we've always done in class, is find our common difference. So over here is plus 1. And then plus 1. Over here, is it multiplying or adding? I think we are adding. Now, watch this. This plus 3 here actually refers to this ketchup blob, the 3 that's being added to each of the designs. So, I keep seeing that we add 3. And when you keep adding 3, this is called a first common difference. Why is it called the first common difference? Because it is adding and subtracting are the same in some ways, and it's a plus 3 every time. So this tells me that it is the function family linear. Okay? Okay, what does that mean that it's linear? Well, we can use y equals mx plus b. And the first common difference, all of this, that is my slope from your oval. And the b is going backwards. Oops, let's do that. Do it again. Zero. So 0 plus 1 is 1. So what number would be here if you're going to have to add 3? Well, you can only subtract with them direction, so that would be a 0, 1. Okay, so then I want to show that 0, 1, or that 1 is my y-intercept. That's the number I'm using here. So y equals 3x and then plus 1. So 3x plus 1 is my answer. And the closest one to that one is letter C. Alright, question number 3. Miss Cohen's garden had 50 weeds when she began spraying her garden with pesticide. Every day, if she sprayed pesticide, there were half as many weeds as the day before. Let X be the number of days and Y be the number of weeds. So remember we said they should have used herbicide, but here is very telling. This tells us X represents the number of days and Y is the number of weeds. Okay, so Miss Cohen goes outside and calls day 0, and there are 50 weeds. She sprays the stuff, it's killing the plants. Oh, pesticide, see, there it is. There were half as many weeds, so what's half of 50? That's 25. So on the next day, 25. Day after that, 12.5. Day 3, another half of that, which would be 6.25. So, how do you go from 50 to 25? You can multiply by 0.50. Multiplying by decimal makes a number smaller. Multiplying by decimal less than 1 is making the number smaller. Here is another way of finding the common ratio. You take your second value, let's call this A2. A2 divided by A1. So you take 25 over 50 and just reduce that. 25 is 25 times 1, and 50 is 25 times 2, and 25 divided by 25 is 1. So you're left with 1/2, and 1/2 is 0.5. Okay, since we're multiplying here, this is our common ratio, which basically means that it is exponential. What is our exponential equation? Y equals ABX. B represents the common ratio, so that's going to be 0.5. The A value is what you started with, which was on day 0 is 50, so 50 is the one that we're going to write there. And if you look at our choices here, A is linear, and D is also linear because they're to the first power. So I'm not going to pick those. And then the difference between these two is actually a common mistake between students that a lot of times they see multiplying 50 times 1/2 and they think that the answer is 1/2 turns into a 2. It's not. So it's not this one. Our answer is going to be C. Is our answer. Which is actually the same question from your quiz. Let's move on to the next question. Classify the graph to the correct equation. Okay, so let's just go ahead and number these. Oops. 1, 2, 3, choice 4, choice 5. Okay, so this one in yellow, if you look at our format, they're all in different forms. So we just have to be careful about which form are they giving us. Okay, this one is x minus 3 and x plus 1. Okay, so if it has no parentheses, which is this one in green, and also this one, they all got cut off. Let me write those out. Negative x, 8x minus 13. This one is x plus 3 squared minus 4. Okay, those that are in green are in standard. So if you write the standard form right above it, you're going to notice some things, right? A is 1, and your B value is 0, and your C value is also 0. So what does that tell us? This is positive, this is opening up, and this is your Y-intercept. Okay, which graph has opening up? So that would be 1, 2, 4, not 3, and not 5. And then which one of these has a Y-intercept of 0? That one's 3, this one is negative 3, this one is 0. So this has a Y-intercept of 0, and because it's smiley face, it is opening up, so that would be choice 2. Let's do the next one down here, okay? Same thing, let's write standard form right above it. A is negative, so this is going to open down, and the C value, that's negative 13. That's our Y-intercept. So you only have two choices, number 3s and 5. not super helpful, so I'm probably going to wait on this one. Let's see if the other one kind of gives me some clues. The reason why is that negative 13 is off the graph. They're both off the graph, so we're going to have to figure out the vertex. One way of finding the vertex is just using x equals negative b over 2a. Your b value is negative 8. Your a value in the green box is negative 1. Oops. So you have negative 8 over negative 2. Negative 8 divided by negative 2 is 4. So my vertex, or axis of symmetry, is negative 4. Let's see. That one's negative 4. And this one is negative 3. So the answer for the second one, or this one, is going to be graph 3. Okay, let's go through the other ones. Let's go through, let's do this one in the middle. Let's do purple. So that one has two sets of parentheses. That one is our factored form. So we read it over here. And I'm going to change the x plus 1 to x minus negative 1. Why? Because the factored form is something like this. X minus p, x minus q. Did you see how the formula has a minus sign? So that means p is 3, and q is a negative 1. Did you notice how I didn't highlight the negative sign in the formula? Okay, so those are my two. Sorry about that. Those are my two x-intercepts, and my a value would be right here. There's no number, so that would be 1. So that opens up. So let's look at all the graphs that open up. Remember, I've already chosen 2 and 3, so those are all done. I can only look at now 1 and 4. Okay, so which one goes through 3, negative 1? There is your 3, there is your negative 1, and it opens up. So 4 is the one in purple. Okay, this is our purple graph. Why? Because it crosses 3, negative 1, which is right there. That's our work for it. Alright, let's go ahead and use now vertex form. Vertex form has one set of parentheses. Let's write the formula right above or below it. Okay, now here we have to pay attention again that is a negative sign. See that? I'm going to have to change it to a minus minus. Again, why do we do that? Because the formula sign has a minus sign in it. Let me see if I can make that a little bit more clear. The formula sign has this red subtraction sign. Okay, what does that imply? That implies that h value is negative 3. The k value is negative 4. Okay, so that's my vertex. And then a is negative. So what does that tell us? It opens down, and we have a vertex. Remember, the vertex is the order pair hk. So this would be negative 3, negative 4. Let's find one graph that opens down. We only have one graph left, so you'll see that's choice 5. This is the vertex, negative 3, negative 4, and it's opening down, and so that is figure number 5. And then naturally that leaves you with the last number 1, but I'm not going to leave it to chance. I'll work it out for you and tell you why it's 1. plus 2. Okay, so vertex form, one set of parentheses, ax minus h squared plus k. Okay, a values 1, so it opens up. It's a positive number. H value is, you see that? 1. Again, the formula has this minus sign, so you have to replicate the minus sign. I know that's so hard for students, but just try to ignore it. Know that they're both, you have a minus sign, you're just highlighting. So I like to tell my students, this is the same. This is the same. This is the same. H here is 1. K is 2. So your vertex is going to be at 1, 2. So it's a graph that's opening up. This is going to the right 1, and that's 2. So that's the order pair 1, 2. Okay. Remember, a common mistake for students is to think that this value, which we got lucky, is the y-intercept. That is not the case. That only works for standard form. So those are your choices, 1 point apiece for question number 4. All right, let's go over question number 5. Each one of these problems refers to the quadratic function y equals x squared minus 2x minus 15. Which equations are equivalent to y equals x squared minus 2x minus 15? Okay, this refers to that chart problem that you guys did in your skills practice. Now, what form do I have here in, let's pick a color. Let's say yellow. What is this in yellow? What form is this? It has no parentheses. So this is standard form. What is standard form? ax squared plus bx plus c. Okay, let's look over here now. What do you notice about choices A and B? In green, these are one set of parentheses, one set of parentheses, and we're using your foldable. What form is that? That is vertex form. And that means this leftover one here is factored form. It has two sets of parentheses, two sets of the parentheses, so that is factored form. Okay, so what does that mean we have to do? We first have to transform the yellow into the green, and then try to see if I can do it by colors. Yellow to green, okay, and then yellow to blue. Let's first get it into the green. Let's get into vertex form. How do I get it into vertex form? Well, you're going to have to do everyone's favorite. You're going to have to do complete the square. Let's complete the square here. I like to write it y equals x squared minus 2x minus 15. I like to move it over there. And really, that's not even enough. I like to do even more. Okay? Well, how do you complete the square? Well, you're going to have to, first my a value is 1, which is good. And then the next thing I'm going to have to do is have to use this formula, b over 2 squared. The b value is negative 2. And then negative 2 divided by 2 is negative 1. And negative 1 squared, negative 1 times negative 1 is positive 1. Okay, so I'm going to write positive 1. Pay attention now. Remember, let's just say you have your bank account. And let's just say you've been dreaming and you want to change your bank account, but the banks want to make sure everything, you can't just get money. And you don't really want to lose your money. So it has to equal 0. Do you notice the green plus the yellow equals 0? Okay, why do I do that? So that in this red box here, you can factor. Let's factor. is 1, B is negative 2, and C is 1. A times C is 1, B value is negative 2. What are my two numbers? My two numbers are negative 1 and negative 1. So I have y equals x, that should have been y equals x minus 1 and x minus 1. Okay, out here you have negative 1 and the negative 15 equals negative 16. Negative 1 minus 15 is negative 16. Okay, then you just put it together. You have, this is how you know you're doing it correctly. You have two of these that are the same expression squared, right? And this is my answer. It's really big. Okay, so let's see. We're trying to get vertex form. To get to one set of parentheses, you have to complete square, which we just did, and the answer is A. Okay. Okay, so that means the other vertex form is not B. Okay, now we just now need to factor the one in yellow. So let's again, we're going through this problem here, and we're trying to factor this. So how do I get to that blue box down here? We're going to have to factor. Let's factor. A is 1, B is negative 2, right? No number there, it's positive 1. Number in front of x, and Z value, which is negative 15. A times C is negative 15. B value is negative 2. My two numbers, when you multiply them, are 5 and 3. But when you add them together, it has to equal negative 2, so this one has to be a negative 5. Negative 5 plus 3 equals negative 2. Remember, you're adding those, the ones in purple, and you are multiplying this direction. Okay, what does that mean for us? When you factor x squared minus 2x minus 15, my answer is going to be, let's just write it out, x minus 5 plus 3. Okay, that's my answer. So that's going to be choice, which one is it? Negative 5 and a positive 3 is choice D is your answer. So the two answers, which equations are equivalent, are A and D. Okay. Part B, what is the vertex of the function? Well, think about this. You have, what is the vertex? Well, you already have one of the forms. That's called vertex form in green. So let's go over here and take something from this. What is vertex form? Y equals, from your foldable, guys. So A is 1. Okay, let me do it again. There has to be this minus sign. So I'm trying to painfully slow. Look, don't circle the minus sign. See that? H is positive 1. Some students think of it as the opposite. K is negative 16. Okay, so what does that tell us? That tells me that the vertex of the function is 1, negative 16. Okay, 1, negative 16. And then it says, what are the roots or x-intercepts of the function? What are roots? Remember, I'm trying to hopefully point this out to you guys. In quadratics, it's just where it crosses the x-axis. Right? Say this is your parabola, and I already know what the answers are. Look. Well, let's do some math here. X minus 5, you set it equal to 0. Set it equal to 0, 0 product rule. Add 5, x equals 5, and x equals negative 3. let's use red. Okay, these are my two answers, 5 and -3. So your graph's doing something like this. Okay, so the red dots are our roots, which are 5 and -3. I need to make sure that you can interchange them, right? You can have -3, -3, comma 0, and 5, comma 0 to get full credit. Just want to make sure. And then D, what is the y-intercept? So if you guys think about each of these forms, what they're asking you is just, what are the key characteristics? Well, the y-intercept form comes from, I did that in yellow, is the standard form, which is your C value, which is -15. So that's -15. So let's just make sure. Pull down option is 5 and -3. Okay, it would also be correct if you pick the other direction. You can also have -3 and then 5. So it has to be in those kind of pairs. And then we said the C value was -15. Okay, that was question number 5. That was problem on the test. Okay, number 6. Determine the number of solutions for each of the graphs. What is a solution to these graphs? The red and blue, these are called systems. And systems, their solutions are intersections. Where do the graphs cross? Where does the red and the blue meet? Okay. So if we look at this graph over here, let's call this graph, I don't know, A. The graphs cross here and here. Okay. So count how many dots? 1, 2. That would be 2 solutions. So this is 2 solutions. Okay. Let's call this one B. Okay, how many times do the graphs touch? Okay, this is one intersection. So this would be one solution. Now, another word you can ask, put into this one, yes, we would just say one solution. So that would be graph. And then this last one, looks like it, but does not. So here, this calls graph C. There is no intersection. Okay, no refers to 0 solutions. So BAC is your answer. Okay, so that's question number 6. All right, last problem. A system of equations is given. Y equals x squared minus 9 and y equals -2x minus 1. What is one solution of the system of equations? Okay. Now, again, what is one solution? It just means one intersection. And really, a system is just kind of like one graph. I should say one coordinate plane. Coordinate plane. Okay, so what are some advantages that we have here? Both these equations are set equal to y. Okay, this kind of lends itself to one way of solving the systems that we've been learning. And you're just going to do a substitution. Let's use my handy dandy highlighter. Every time you see y, you're going to write x squared minus 9. On the second equation, instead of writing y here, we're going to write x squared minus 9. So instead of writing this y, we're going to write x squared minus 9. On this side we have this. Okay? So let's write out our steps. What did we do first? We did a substitution. Okay, what's the second thing we're going to do here? We're going to set equal to 0. Let's do that. Okay, so you have to think ahead. I could move the green to the right side, to the purple, or I can move the purple to the left side, the green side. And I'm going to choose to move the purple to the green. Why? Because it'll keep the A value positive. Watch. Okay, pay attention now. There is no like terms. I'm going to put it in between. If you needed some help on that one, where is my, here it is. Let's see if I move this over. Watch. Do you see how there's actually something missing in the middle there? We're actually going to need this for our next chapter. Is I called it a placeholder. You have x to the second. Well, what's x to the first? It's a 0. So if you want to, you can have that. So your C value is -9. Okay, I'm also going to move this -1 to the left side. And now we have this. X squared. 0 plus 2 is 2. And -9 plus 1 is -8. -2x plus 2x is 0. And -1 plus 1 is also 0. So now we have it x equals 0. Alright, what do we do next? We need to check discriminant. Okay, what is the discriminant? It is b squared minus 4ac. Okay, my b value, a value, and c value. Okay, so a is 1. C is -8. And my b value is +2. Remember, substitutions are always in parentheses. Always. Let's simplify this. 2 squared is 4. -4 times 1 is -4, and -4 times -8 is +32. 4 plus 32 is 36. So, we always needed to kind of put an inequality in this box and compare it to 0. Well, what inequality can you write in there? It is greater than. 36 is bigger than 0. What does that mean? There are 2 real solutions. There are 2 intersections. Okay? So, we just found the discriminant. Now, we're going to solve for x. How do you solve for x? You can use all those different methods. Quadratic formula, you can use, when you write them out, quadratic formula, you can solve this by graphing, you could use the square root method, you can use your favorite, completing the square, or the easiest one but doesn't always work, factor. Let's see if it's factors. Okay? Let's see. A times c, my b value, a times c is -8, b value is 2. 2 numbers that multiply to be 8 are 1 and 2. And could they add to be 2? Well, this one has to be a negative. Remember, if a value is 1, you don't have to use the box. Okay, what are we doing? We're solving for x. So I can just set that equal to 0 now, each of those. 0 product rule. One of these expressions has to equal 0. And then we're just going to solve it. So I get x equals -4 and x equals 2. Okay. We just solved for x. The last thing we need to do now is solve for y. Solve for y. Okay, how do you do that? You're going to pick one of our formulas, And I'm going to pick the easiest one. I think the easiest one is the linear one. Well, too dark. Let's choose green. How about that? And I'm going to use this one right here. Alright, so let's go ahead and write down that problem there. Y equals negative 2x minus 1. And basically you're going to have to substitute that number in twice. Too many problems here. Okay. So now I'm putting this one here, and this one here. Okay? Y equals negative 2x, negative 2 times negative 4 minus 1. So this is negative 2 times negative 4 is positive 8, and you get 7. Okay? So that order pair is negative 4, 7. And over here, you have y equals negative 2 times x, or 2 minus 1. So negative 2 times 2 is negative 4. Negative 4 minus 1 is negative 5. So my two order pairs are 2, negative 5. Okay, so that means if you wanted the next step, what we're doing here is you just create order pair. Okay, so those are my two answers. Let's write that up there. 2, negative 5 can be one of them, or the other one was negative 4, 7. Okay, again, what does that look like on our graph? So in green, you have a standard form, Y-intercept that's negative 9. If you factor that one, b value is 0, right? You get 3 and negative 3. So x plus 3, x minus 3, and you solve those, and you get x equals negative 3 and 3. So the graph crosses here at 3, negative 3, and then it has a y-intercept of negative 9. So this green graph looks like that. Let's do that with a pencil. It's a little bit lighter. And then in purple, this is in y equals mx plus b. So my b value is negative 1. And it has a slope of negative 2, which is negative 2 over 1. So that would be down to right 1. So you would do something like this, down to right 1. And you can just something like this. And then those 2 that we just solved for, 2, negative 5, is right 2, and that's negative 5. So this is your first intersection. And then let's pick one in yellow here, 2, negative 5. Negative 4, 7. Sorry. Why did I write that? That's negative 3, and that's positive 3. Okay, let's go back. Okay, go back to yellow. We're trying to graph negative 4, 7. Left 4, so past this one. And then way up here somewhere, that's the intersection. Graphs cross. Negative 4, 7. Okay? And that's why it is 2 solutions. So in there, you just have to put one of those order pairs, 2, negative 5, or negative 4, 7. I just wanted to show you guys the graph to kind of help you visualize what we're doing. I love math.
Love math. You don't love math? What's wrong with you? I love math.